All right, let's take a look at our next example. This is coming from page 557. It's number 30. So a company with a large fleet of cars hopes to keep gasoline costs down and sets a goal of attaining a fleet average of at least 26 miles per gallon. To see if the goal is being met, they check the gasoline usage for 50 company trips chosen at random, finding a mean of 25.02 and a standard deviation of 4.83. Is this strong evidence that they have failed to attain their fuel economy goal? A lot of stuff, basically do a hypothesis test. All right, so hypotheses. The null hypothesis will be that the mean is equal to 26. Right, we're dealing with means now, and so it's going to be about mu. Our alternative hypothesis will be, all right, so it's going to be mu, and it's going to be 26. We're looking to see, is this strong evidence that they have failed to attain it? So, right, like you could do either side. If you do greater than, mu is greater than 26, we would be trying to prove or give strong evidence that they met it. We're just looking for strong evidence if they haven't met it, so it's going to be less than. That's our hypotheses, our model. Check our same conditions. We've got random. We have less than 10%. And we have nearly normal. All right, random. We were told it was a random sample. Less than 10% if there are more than 500 trips. And nearly normal. We don't have any data. We can't make a histogram. Can't make a histogram. We would really prefer to. If we had the actual data, we would, but we don't. So let's think a little bit about it. I mean, ways it would be not satisfied. Like, this isn't going to be strongly skewed. Our sample size is large enough that we can get away with most things. We have a sample size of 50. So we can get away with most things unless it's extremely skewed. The only way it would be extremely skewed would be like somebody siphoning off gas for their own personal use from the company car, you know. And you should look at a histogram and rule that out. But if it's just people driving as per normal, it might not be normally distributed, but at least it won't be like strongly skewed. It might be a little skewed because some people drive super aggressive or something, but we should be fine. Alright, our mechanics. We are doing a one sample t-test. Alright, so we have a t-model, not a normal model, t-model, centered at 26, which is the value from our hypothesis. We want to see the probability that it is less than, what is this? This is 25.02. That's the, this is mu. This is x bar from the sample. Alright, our t-score is going to be value minus the mean over the standard deviation, which is the sample standard deviation, 4.83, over the square root of sample size. Alright, 25.02 minus 26, I didn't need to do that, over 4.83 divided by the square root of 50. Our t-score is negative 1.434. Alright, so with a sample size of 50, we should be roughly close-ish. Okay, so there's a couple ways to do what we're doing now. One is TCDF. Lower would be negative 9. Upper will be our negative 1.434. And then we have to put in degrees of freedom as well. Our sample size is 50, so we have 49 degrees of freedom. This will get us an answer there. We could also jump to that t-table in the back of the book. We are at 49, basically 50 degrees of freedom. We're looking for 1.43, which is, yeah, negative 1.434. Positive 1.434 will be the same thing. So 50. We're in between those two. It's so like one tail, like it doesn't matter which side, it is symmetrical. So yeah, we'll be in between those two. If we go up, we're doing one tail, so we'll be in between 0.05 and 0.1. We won't get an exact answer, but we'll know roughly where we are. So that means our p-value, we'll use the calculator one, 0.07, 89. Alright, that's our p-value. Let's do this all on the calculator as well, before we forget. Okay, stat. Tests. We're doing a t-test. Our null hypothesis is 26. We're doing it from statistics. We don't have the data. We had 25.02. We have, what, 4.83. 4.83. And our sample size is 50. And we want to see if we're less than. So yeah, we get the same t-score. We get the same p-value. You have to write this stuff down. If you're, you gave it those three, right? You gave it X bars, sample standard deviation, and sample size. If you're doing it from data, you should write that down, but otherwise, that was in the problem. You don't have to write that down again. But you should get the t-score and the p-value from there. Even sunnier now. All right, so now our conclusion. With a p-value equals 0.0789, which is greater than 0.05, do not reject the null hypothesis. We do not have strong evidence the fuel economy, the fleet fuel economy is below 26 miles per gallon, right? we have some evidence, but not strong evidence. Right? I mean, p-value 0.07 or 0.08, like, it's down there, but, you know, we'll use 0.05.